Laguerre polynomials. In this video, we will generate the dataset of the Laguerre polynomial using Taylor-Maclaurin series sum, array formula, combine, data validation, and LINEST Polynomial Regression. Here we have the definition of Laguerre polynomial, which is y equals the summation of a times x to the power k, where the value of a is negative 1 to the power k times combine of n comma k over k factorial, and the value of k is from 0 to n. And our n will be equal to, let's assign this from 0 to 8. 0 to 8. Now we have values of n from 0 to 8. And our value of k will be 0 to n, which is equal to sequence of n plus 1, 1 column, 0, starting from 0, incremented of 1. So that if that's 0, then our value of k is 0. 1, the value of k is 0, 1. 2, n equals 2, 0, 1, 2. 3, our value of k is 0, 1, 2, 3. Now we can go to the series sum, Taylor-Maclaurin series sum. So array formula, series sum of the x values raised to the power starting from 0, incremented by 1, and the coefficients will be this range. Now we fill in the coefficients. So here we have the Laguerre polynomial, which is the trend line equation, and the trend line. Now we go to the coefficients, which is array formula. Okay, we start with negative 1 to the power k. So if this is empty, this should be 0. So we have to correct this. So if k is empty, then 0, otherwise calculate. Now that's correct. Now we continue with the second term, combine of n comma k. So times n times n combine n comma k. And the last term is divided by k factorial. Divided by factorial of k. So here we have the coefficient. So 1, so the polynomial is 1 minus 3x plus 1.5x squared minus 0.166 x cubed. And the rest are 0. Now we fill in the regression coefficients, which is this one. We fill up the 1 comma x matrix and use LINEST. So here we have we set this aside. And we fill in this. So this is equal to array formula of the x values raised to the power 0 to our maximum will be 8. Now that we have the 1 comma x matrix, we can enter the LINEST. LINEST of data y and data x. Enter. So here we have the coefficients. Let's check. We'll use this against our trend line coefficients. So we start from 0. At n equals 0, our Laguerre polynomial is y equals 1. So 1 times x to the power 0. At n equals 2, our value for y, Laguerre polynomial y equals 1 minus 1x. So it's 1 minus 1x. So 1 minus 1x. At n equals 2, our Laguerre polynomial y equals 1 minus 2x plus 0.5x squared. 1 minus 2x plus 0.5x squared. The rest are 0. And at 3, n equals 3, Laguerre polynomial y equals 1 minus 3x plus 1.5x squared minus 1.1667 x cubed plus, this is already 0. So that's 1 minus 3x plus 1.5x squared minus 0.1666x cubed, which matches to our trendline equation and our expansion coefficients. N equals 4. Our regression coefficients match to our expansion coefficients. And the trend line, which is 1 minus 4x plus 3x squared plus minus 0.667x cubed plus 0.0417x to the fourth, and the rest is 0. So it's 1, that's 1 minus 4x plus 3x squared minus 0.66x cubed plus 0.041166, which matches to our trendline equation. At n equals 5. So our regression coefficients match to our expansion coefficients on our trend line. 1 minus 5x plus 5x squared plus or minus 1.66x cubed plus 0.208x to the fourth minus 8.33x to the minus 3x 10 to the minus 3x to the fifth. So it is 1 minus 5x plus 5x squared minus 1.66x cubed plus 0.20833x to the fourth and minus 8.33 times 10 to the minus 3x to the fifth. At n equals 6, our Laguerre polynomial y equals 1 minus 6x plus 7.5x squared minus 3.33x cubed plus 0.625x to the fourth minus 0.05x to the fifth minus 1.39 times 10 to the minus 3x to the sixth, and the rest is 0. It's also 1 minus 6x plus 7.5x squared minus 3.33x cubed plus 0.625x to the fourth plus 5 or 0.05 x to the fifth plus 1.39 x to the 1.39 times 10 to the minus 3 x to the 6, and the rest is 0. The regression coefficient match to our expansion coefficients. At n equals 7, the Laguerre polynomial y equals 1 minus 7x plus 10.5x squared minus 5.83x cubed plus 1.46x to the fourth minus 0.175x to the fifth plus 9.72x times 10 to the minus 3x to the sixth plus 1.98 times 10 to the minus 4 x to the seventh. So that's 1 minus 7x plus 10.5x squared minus 5.83x cubed plus 1.45 times x to the fourth plus or 0.175 times the x to the fifth and 9.72 times 10 to the minus 3 x to the sixth and 1.98 times 10 to the minus 4 x to the seventh. At n equals 8. So our Laguerre polynomial y equals 1 minus 8x plus 14x squared minus 9.33x cubed plus 2.92x to the fourth minus 0.467 x to the fifth plus 0.0389 x to the sixth minus 1.59 times 10 to the minus 3 x to the 7 plus 2.48 times 10 to the negative 5 x to the 8. That's 1 minus 8x plus 14x squared minus 9.33x cubed plus 2.916 x to the fourth minus 0.466 x to the fifth plus 0.0389 x to the sixth. This is negative 1.59 x x to the minus 3, and 2.48 x to the minus 8, x to the 8. So this completes the Linus polynomial regression of the Laguerre polynomials and the Taylor-Maclaurin series sum expansion of the same Laguerre polynomial using array formula, combine, and data validation.